Good evening, everyone. The topics I'm going to speak on is firstly, what is IC fabrication? Second, the various steps to prepare fabrication of IC, and finally conclusion. So, what is IC fabrication? Semiconductor device fabrication is the process used to create the integrated circuits that are present in everyday electrical and electronic devices. It is a multiple-step sequence of photolithographic and chemical processing steps during which electronic circuits are gradually created on a wafer made of pure semiconductor material. Silicon is almost always used, but various compound semiconductors are used for specialized applications. The entire manufacturing process, from start to package chips ready for shipment, takes 6 to 8 weeks and is performed in highly specialized facilities referred to as fabs. The various steps involved in IC fabrication are wafer preparation, wafer processing, and testing and packaging. So, the first process is wafer preparation. Small chunks of polycrystalline silicon are placed in the quad crucible with small amount of chemical dopant elements needed to produce either N or p-type silicon. The crucible of silicon is heated to molten state with the help of a clamp seat, or small crystal of doped silicon is lowered into the melt. Once the seed crystal touches the surface of the silicon, the wet temperature is reduced. As a result, the silicon melt attach themselves to the seed crystal. Once the crystal starts to grow, the seed crystal is raised out of the silicon mold. The seed is rotated in one direction while the crucible in its holder is rotated in the opposite direction, and the single seed crystal becomes a huge ingot. This method is Zoklar's key method of crystal growth. The landed crystal of silicon is sliced into round crystal known as wafer. The wafer is then cleaned, polished, and checked for flatness and defects before it can be used. One wafer could have hundreds of seeds in it. The next process is wafer processing, and the first step under wafer processing is epitaxial growth. Growing a new layer of silicon on the top of another layer of silicon while maintaining the latest structure is called epitaxial deposition, which can be done in several ways. One of the ways is chemical wafer deposition. The next step is oxidation. There are two types of oxidation. One is wet oxidation and the other one is dry oxidation. When the oxidizing atmosphere contains water vapor and the temperature is between 90 degrees Celsius to 1000 degrees Celsius, silicon gets oxidized to SiO2 and also hydrogen gas is generated, and this is under wet oxidation. However, quality of the oxide grown is comparatively slow. Now, dry oxidation. Oxidizing atmosphere is pure oxygen and the temperature is between 900 degrees Celsius to 1200 degrees Celsius for different growth rate of oxidation. This process is slow, but the quality of oxide growth is superior. And the third process is etching. Etching is the removal of unprotected materials. There are two types of etching. One is wet etching and the other is dry etching. So, what is wet etching? Wet chemical etchants are used by immersing the wafers into baths of liquid chemicals. The exposed fields will be etched every day, leaving unetched those regions of the field that were masked with photoresist of other fields. Now dry etching. A low-pressure gas is used in the channel by applying high electric field across the two electrodes. Some of the gas atoms are ionized, producing positive ions and free electrons and creating a plasma. The fourth process is photolithography. It is the process of transferring an image from a photolithography mask to a resultant pattern on a waveform. A photoresistive polymer film is applied to the silicon wafer, dried, and then exposed with the proper geometrical patterns through a photomask to UV light or other radiation. A photoresist, positive or negative, is placed over the substrate. Photolithography is a fundamental part of every step in the IC fabrication process, whether for implantation, doping, epitaxial layer formation, or any other surface. The fifth step is diffusion. It is the process of doping a wafer, causing creation of P or N-doped regions where the silicon surface is not protected off-site. It consists of two steps, pre-deposition and drying. In pre-deposition, dopant atoms mixed with an inner gas are introduced into the furnace at 100 degrees Celsius. The atoms diffused onto a thin layer on the surface of silicon. In dried-in, the wafer is heated in nitrogen gas with a dopant. This distributes the surface diffused on a thin layer on the surface of silicon. The sixth step is ion implantation. It is a selective doping process that drives ionized dopant, either boron, arsenic, or phosphorus atoms into the semiconductor wafer at room temperature. The resulting atoms are accelerated by high voltage and form narrow beam that is directed into Windows pattern in the wafer surface. The ions have enough energy to penetrate the surface and then slope to rest within the wafer at depths determined by the manufacturer. And the seventh step is metallization. Deposition of a conducting material to form an interconnection leads between the circuit component parts on the surface of the chip is called metallization. Due to various advantages, aluminum is most commonly used for the various metallization process. And then, after all these steps, finally, the wafer is tested and packed. Now coming to conclusion, models describing the steps used in fabricating ICs have also been incorporated into process simulators. It is therefore quite possible today to build new semiconductor structures and predict their performance using these computer tools. Thank you.